Friends, let's discuss about the next topic of the chapter, periodic table, and that topic is anomalous properties of second period elements. Actually, there are different properties that belongs to the second period elements is exceptionally different to the rest of the member of the same respective groups. And under this category, the elements which are coming, that is lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. These elements having a different exceptional properties because of some of the reason, because of the some reason. That reason we have to discuss first, then we'll discuss about the some of the properties that belongs to the anomalous behavior. The reasons are, if you are going for the reasons are smaller size, small atomic size. The second reason is the high QR value. The third reason is electronegativity is very high. Electronegativity is very high. The fourth reason is d orbitals is not there. Absence of d orbitals. These are the some basic reasons why the second period elements having anomalously different from the respective members of the same group. These are the some reason. Atomic size, okay. The properties which deviate from the other members are due to the smaller size, hydration enthalpy and polarization is very high. Polarization and hydration enthalpy is very high. Polarization means the distorting power of the cations or anions with the in the bond. The separation of electronic density in the bond is called polarization, and the cations having very great tendency to separate the charge density in their bonds, that is called polarization. And due to the smaller cationic size, they are having a great polarizing power. Hydration energy means the cations and anions when associated with water molecules, what amount of energy they actually released out, that is also called hydration. So that is also depends upon the cationic or anionic size, which is smaller in the case. Exceptionally, the second period elements have the great ionization enthalpy value and very high electron gain enthalpy value because of the charge density having a great affinity towards a charge that actually relate to the ionization value and electron gain enthalpy value. This is also based on this high QR value. Okay, this is also exceptional behavior. You can see the some of the exceptional behavior that actually relate to the second period elements, that is beside this the maximum covalency never exceeds more than 4 in period second, because they are having only s and p orbitals, means they are having total number of orbitals are 4. Total number of orbitals are 4, and due to which only 4 orbitals can belongs to the chemical bonding. So the maximum covalence is 4. For example, BF4 minus, you can see this BF4 minus having 4 covalency, but the next member of the same group ALF6 having a 6 covalency in the case of aluminium. You can see the same way nitrogen also having a covalency 4. The restriction is because of the absence of d orbital. The next property is lithium compounds, some of the lithium compounds and beryllium compounds are predominantly covalent, even they are expected to be a ionic. This is because of the smaller size and great polarizing power. The great polarizing power and smaller size actually help to make a covalent bond of lithium and beryllium in their compounds. Even the lithium fluoride and beryllium fluorides are ionic, but they are oxides, and the rest of the halides are covalent because of the polarizing power and atomic size. The second period elements, when form pi bond, they always form p pi and p pi bond. The double and triple bonds having a 1 pi and 2 pi bond respectively. So when they participate in the pi bond, the p orbitals only involved in the pi bond, and the rest of the members can make a p pi and d pi also. P pi and d pi indicating that d orbitals participate in the pi bond formation. This is for the rest of the member. Second period elements can only form a p pi bond. They show a diagonal relation. The diagonal relationship means the sum of the members like lithium, beryllium, boron having some similar property to the diagonally placed element like magnesium, aluminium and silicon respectively. This is called diagonal relationship. This is based on the similar cationic size of the elements of lithium, beryllium and boron. So diagonal relationship. The other anomalous behavior is oxygen, nitrogen are diatomic because of the enormously restricted catenation power due to the extra lone pair repulsion, and other member like phosphorus is tetraatomic and sulfur is a octatomic S8, the polyatomic molecules because of the same reason. Carbon having a most catenation power because of the same exceptionally reason, having a more a strong covalency 4 and the moderate electronegativity in the case. Water is a liquid at room temperature and H2S is a gas because of the same anomalous behavior, because oxygen having a great tendency to form a additional attractive bond with hydrogen called hydrogen bonding students. Even H2S, sulfur having no tendency to make a hydrogen bond. This is the reason. Ammonia having a great boiling point than phosphine because of the same reason. Nitrogen always participate in the hydrogen bonding. Water is a universal solvent because of the great polarization power, great hydration power, great electronegativity and having a great tendency to make a hydrogen bonding. So most of the ionic as well as covalent compounds can be dissolved in the water because of the same reason. This is also anomalous behavior of oxygen in the water molecule. So many of the property that actually relate with the second period elements are because of the some anomalous or exceptional behavior of these elements. You have to be learn the reasons and the different properties belongs to these group period elements and their compounds. Students, go through this lecture and try to learn this concept. We'll discuss about some more concept in the next upcoming lecture. Thank you.